This is the last section of chapter 9, quadratic formula. So we've been dealing with ax squared plus bx plus c is equal to 0, and we just got to make sure that the first number a is not equal to 0. Now, if you ever have this, then you can always use the quadratic formula. I think when you hear that, you're probably getting frustrated because why didn't we just do this from the beginning? This is honestly, for me, just like the last case scenario, because factoring, when we practice that, it becomes very easy. And then this should be used when factoring is not possible. If you remember from before the worksheets and the tests, it said that if it was not factorable, then write prime, right? Write the word prime. So this is when we can actually solve a quadratic equation when something is prime. So this is our quadratic formula. You have x equals, because remember, if you remember, whenever we factor, we get like x minus 5 or x plus 4. This is just an example. And then you would get two answers, right? Or you would get one answer, or you would get no answers. So x is equal to negative 4 and 5. So that's kind of the same thing, same idea here that we're looking for. We're looking for an x value from this quadratic formula. And this formula is negative b, or the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Yes, you will have to remember that, okay? But there's actually a very easy way to remember that. Once you get to class, I'll show you how to remember that. So this first example here, it says solve the following equation using the quadratic formula, round to the nearest tenth if necessary. So here I have x squared minus 12x is equal to negative 20. So you got to make sure. So in this case, you got to make sure zero's on the on one side. So I'm going to add 20 on both sides for me to get x squared minus 12x plus 20 is equal to 0. Now, honestly, this is factorable. Okay, this is factorable. If I were to factor it, I would get x minus 2 and x minus 10, and this would actually work. Okay, and so I'm going to tell you right now that the solutions are 2 and 10. Alright, but I just want to show you using the quadratic formula just so that we're kind of familiar with it. Okay, so again, we have the opposite of b. So in this case, b is negative 12. So x is equal to the opposite of negative 12 plus or minus the square root of b squared, which is negative 12 squared, minus 4 times a, in this case is 1, times c, which is 20, all over 2 times a. Okay, so that's what we have right now. Let me just erase this answer so that I have a little bit more space. So we have, if we were to break this down, x is equal to a positive 12 plus or minus the square root of negative 12 squared is 144, minus 4 times 1 times 20 is 80, all divided by 2. And so I have x is equal to 12 plus or minus 144 minus 80 gives me an answer of square root of 64 divided by 2. And the square root of 64 gives me 12 plus or minus 8 over 2. Now, here's where we have two possible answers. We have 12 plus 8 divided by 2, which is 20 divided by 2, so x is equal to 10. Or we have 12 minus 8 divided by 2, which is 4 divided by 2, which is 2, and so that's where my solutions come from. X is equal to 10 and x is equal to 2. Okay? Why don't you try B and C for practice and see if you can get that, and then we'll check that in class. I actually did B for you just to make sure that you kind of have the concept. My two possible answers for x is equal to 3 halves and negative 6. Okay? So C, I'm going to assign for homework to check for the next day. So this table here I got from the textbook, and it actually gives you a pretty good idea of when to use the quadratic formula or when to use which method. Because we know now 5 methods. We know how to use the factoring, which we did in chapter 8. So it gives you a description here. We know when to use the graphing, right? On a graphing calculator, we know when to use the square roots. This is when x squared, so if you have like x squared is equal to 49, and then you take the square root on both sides, if you remember that from chapter 8. And then completing the square, this was section 9.4. And then now we have the quadratic formula. So these are all different cases. So take a minute just to kind of read the description of when to use which method, or when it would be easiest to use it. Now, something related to the quadratic formula, there's something called a discriminant. The discriminant is the expression under the radical, so b squared minus 4ac. So if you remember the formula, opposite of b plus or minus b squared minus 4ac, that part right there is called the discriminant. And what that discriminant actually tells us is it can be used to determine how many real solutions in a quadratic equation there are. So the options are 0 solutions, 1 real solution, or 2 solutions. So how can we figure that out? So let's use the discriminant here. In this equation we have x squared plus 2x plus 5 is equal to 0. So the discriminant is b squared minus 4 times a times c. And then if I evaluate that, then I get 4 minus 20, and I actually end up with a negative number. And the graph, so this is the graph right below this is actually the graph of the function, and you'll notice that this parabola does not cross the x-axis. And when does that happen? That happens when the discriminant is negative, so that actually means that there are 0 solutions. So negative discriminant gives you 0 solutions. And so if we do this second one, we have the set of 10 squared minus 4 times 1 times 25. 10 squared is 100. 4 times 1 times 25 also gives you 100. This gives you an answer of exactly 0. When the discriminant is exactly 0, that parabola, only the vertex ends up on that x-axis, so there's only one solution. So the discriminant, when it's equal to 0, gives you one solution. And then let's try the second one. Or I'm sorry, the third one. So I have negative 7 squared minus 4 times 2 times 2. That gives me a positive 49. Minus 4, negative 4 times 2 is 8, and then times another 2 is 16, and this gives me a positive answer. When you have a positive discriminant, and again you can look at the graph right below it, when you have a positive discriminant, that gives you a gives you 2 real solutions. So why don't you actually do examples 2a, b, and c. For c, this should not be a decimal. It's just a whole number 9 in front. And make sure, again, that it's equal. The whole expression is equal to 0. So for a, you got to get rid of that negative 3 and bring it to the other side. And then just go ahead and do b squared minus 4 times a times c to determine how many real solutions there are. And then we'll bring that back to class to check our answers.